Okay, this one's pretty tricky. So we got to really understand the problem and everything that's going because there's lots of different types of mathematics going in here that we've got to be careful about. So we've got a person that's training for a triathlon. So there's three legs to this. First leg's a swim, which is across a pond. So it goes from S to X here, and the distance from S to O is 2. So that's our reference there. Um, then the second leg goes from X to Y along a straight road OY. Now, the distance of the point there from O is A, and that distance from O to Y is 4. So the ride there is from X to Y, and then the last part is a jog, and it goes around from Y to F there. So that's what's happening. Now, what can happen? The swim she can go at 6 kilometers an hour, the bike ride at 12 kilometers an hour, and the jog at 8 kilometers an hour. So we've got variable speeds that she's going to be travelling along there. So we've got to work out distances, we've got to play with the speeds. Because the question is saying, well, it wants us to work out the time that she takes to start off with. It's equal to that expression. Well, that's not a pretty expression. So what we've got to do is play around with all three there. So we get our distances. Our distances, Sx there. Well, I'm going to use Pythagoras' theorem because you've got 2 and you've got a there. So the Sx would be equal to a squared plus 4. Pythagoras' theorem there. And then xy, well, that's not too bad because the distance from oy is 4 and then ox is a. So we get 4 minus a. And then if you look here, that's going to be a radius of 2 because that's the same distance as 2 there, same distance there. So that gives us 2 pi times the 2 over 4, which is because it's a quarter. So 2 pi r over 4 gives us pi. So that's just the distance from y to f. So that's a set distance. It's always going to be pi. So the time taken there. Now if we remember our relationship, so speed is equal to distance over time. So if we manipulate the speed to get time by itself, we get time is equal to distance over speed. So we have to remember that relationship because to get the time for the swim, it would be the distance, which is the square root of a squared plus 4, over the time she can swim it, so which is 6 kilometers an hour. And then for the distance of the bike ride is 4 minus a, she can travel at 12 kilometers an hour. And then the run was at pi divided by 8. So it's going to take her pi on 8 hours. So that's just constant. So now we're still going to get to this. So we want now the total time is all these three added together. So you see that's where we put all three together. So all three times come together. We put in 1. And then we wanted it with 1 common denominator. Again, much easier to play with this if we want to find a maximum or minimum, which we're going to, but they want this. So it's about manipulating that expression. So getting a common denominator, multiply the 6 by 4, so this expression gets multiplied by the 4. 2 gets multiplied by 12 get multiplied by 2, so the 4 minus a gets multiplied by 2 there, and we get 2 times the 4 gives us the 8 there, and then the 2 times the a gives us the minus 2a. And we get the 8 multiplied by 3, which gives us the pi, which there's our 3 pi there. That's where we put the 8 plus 3 pi together because they're just the constants. Wow, that's not an easy one to get because there's lots of playing around there. So deriving this, well, we derive dt with respect to a. So when we derive this, still all going to be on 24. That's going to get the chain rule applied to it. That's going to just derive to be 2, and that's a constant. So that's going to derive to give us 0. So that's totally gone when we do that. So there's the chain rule. The 2 it was out the front, and we brought the half down. We multiplied by the 8, got the a squared plus 4, power of the minus half times the 2a, which was the derivative there, and minus the 2, which is the derivative of the 2a we had there. And then we start to set it equal to 0. The 24 makes no difference, so it's really just what we've got here. So the two lots of a squared plus 4 would equal 4a. So I've started to manipulate it there, taking the 2 across and 4a and multiplied by everything through there. So it's just manipulating this algebra to get to this part. And then we get the square of the both sides to get rid of the square root. So 4a squared, and we've got an a squared plus 4. Now the 2's gone there, so it mustn't have actually been there, so it shouldn't have been there. Which gives us our a squared. That gives us, we subtract out the a squareds, gives us 3a squared equal to 4, or a squared being equal to 4 on 3. So, and then that's gone there to this part. So 2 on root 3. So that's where our minimum time occurs. Again, I would go and test in the first derivative. That's going to be a lot easier to test it. And putting something smaller than 2 root 3, something greater than 2 root 3 into the expression for the derivative, and seeing that you're going to get a negative 0 maximum, and that's going to give us a minimum there. Okay, so again, have a look at the algebra that we do and the derivative, and take really so. Again, I've done it with this one. I would go back and use that as the derivative, doing the question again, because it's a bit easier to manipulate those, because that derives to 0, that just derives to minus 1/12, and then that just is the chain rule on that. So that's probably a bit easier to solve if you're going to have a practice with this one.